How do ESMs predict future global climate change? Imagine trying to forecast the weather months or even decades ahead. That's what scientists do when they use Earth system models to predict how our planet's climate might change in the future. These models are like super detailed virtual Earths, built on the laws of physics, chemistry, and biology. They simulate how the atmosphere, oceans, land, and ice all interact and influence each other over time. Earth system models use complex mathematical equations to show how energy and matter move through the Earth system. For example, they track how sunlight heats the surface, how heat moves through the oceans, and how carbon dioxide cycles between the atmosphere and forests. By inputting current data like temperature, greenhouse gas levels, and human activities, these models can project what might happen if certain trends continue. The process starts with the basic principles that govern weather and climate, such as fluid flow and heat transfer. These are the same laws that control how wind blows and how rain falls. The models also include biological processes like plant growth and chemical reactions like carbon absorption by forests. This helps capture feedback loops, where one change can cause others to accelerate or slow down. To check if they are reliable, scientists test these models by running them backwards in time. They input past data and see if the models can recreate recent climate changes. If the models match what actually happened, it boosts confidence in their future predictions. Because the climate system is very complex and some processes are hard to simulate perfectly, scientists use many models and compare their results. When different models agree on key trends, it shows those predictions are more trustworthy. Earth system models also explore different future scenarios based on how humans behave. For example, they simulate what might happen if greenhouse gas emissions stay high or if we reduce them significantly. This helps policymakers understand potential risks and plan strategies to limit climate change or adapt to its impacts. Recently, scientists have combined traditional physics-based models with machine learning techniques. This hybrid approach improves regional predictions, like local rainfall or temperature patterns, making the forecasts more detailed and faster. These advances help decision-makers prepare for specific climate impacts in their communities. In short, Earth system models predict future global climate change by creating detailed virtual representations of Earth systems. They use physical laws, test their accuracy against past data, and run different scenarios based on human actions. This process helps us understand what might happen and guides efforts to protect our environment and build a sustainable future.